I'm Mikayan, and today I'm with my teammate who is Everlianzi, Pui and also San Xin Yu. We'll together present about the question 3. So for the question 3, the vertical ground reaction force of the 61.16 kg around 600 Newton subject while running is approximated opposite. The thick dashed line represents the body wave. So for question 3a, how long is she in contact with the ground? So in this case, the graph only shows for 0 to 250, so we will take 250 as the duration that she contact with the ground. So to 250 milliseconds converted to seconds is 0.25 seconds. For question 3b, what is the net impulse she experienced during the contact phase with the ground? So in order to calculate the net impulse, we use the method area under graph. So we calculate for 6 area under graph and we sum it out. Then we will get the net impulse. So in this case, our total net impulse is equal to 195. So for question 3, if she leaves the ground with the same center of gravity vertical speed as she lands with, what must the speed be? So in this case, we can use the formula impulse equals to change in moment. So Ft equals to m squared Vf, and we change the formula into m time in bracket Vf minus V1. So in this case, Vf is equals to negative V1. So we can calculate out the V, which is V equals to 1.594 ms. So the vertical speed must equals to 1.594 ms. So for question D, how would you use this information to determine where during the support phase of running her vertical velocity is equal to 0? So actually no calculation is needed for this part. But in order to show the precise point of 0 velocity, we have undergo some calculations. And so how do we calculate this? So in order to calculate the point of 0 velocity at the time of what? So we have to, the net impulse is needed to achieve 0 velocity, which is the net impulse is equal to 0. So we use the same formula as above. Ft equals to m in bracket times with in bracket Vf minus V1. And we set our Vf is equal to 0, and our Vi is the value of the value that we calculate from question C, and we get our impulse is equal to 97.49 ns Newton second. So then we calculate the impulse for the 0.1 seconds, then which is 0.1, which is we sum it out the first three triangle, which is the triangle 1, triangle 2, and also triangle 3. And then we get 40 Newton seconds. Then we use the impulse of 0 velocity minus with the impulse for 0.1 seconds. Then we get 57.49 Newton seconds. So to find out the times, so we let the Ft equals to 1400 times with t, and this actually equals to the 57.49. So we found the t is equals to 0.041 seconds, and we have to add 0.1 seconds that had already elapsed. So therefore we will get 0.141 seconds. So the point of 0 vertical velocity occurs at time 0.141 seconds. So I think that's all for us. Thank you.